Hi good people, Titus here for part 5 of our Asteroids mini-series, and in this video we'll work on creating the asteroids and adding the collision code so we can prepare for the win-loss conditions for this prototype. Let's not waste any time and jump right into it. Okay, we're going to start by going into the Blender folder, and we'll create a new folder. We'll just call this one the Asteroids, or Asteroid, depending on how many rocks you're making. I went ahead and just modeled a simple rock in Blender. You can use any static mesh you want. I'm just going to import that. And then I had some textures that I created from Marmoset that I'll bring in as well. I'm then going to go to the materials folder, and we're going to create a new material. We'll call it m_asteroid. And then we're just going to quickly make a very basic color material for this rock. So I can go back to my Blender folder and I can select my textures that I got from Marmoset, bring them in, and then they're pretty straightforward. This one is the albedo, which is just color, so we can plug that into the base color here. And then this one right here is the normal, so you just take the RGB channel and go into the normal. This one's a little different, it's a mix map. Which means it has several textures in it, not just one. So on the red channel, we have the ambient occlusion. On the green channel, we have the roughness. And on the blue channel, we have the metallic. And those are just settings specific to Marmoset. So, and then we have our completed texture here. We'll save that. We're gonna go to our blueprints folder, and we're gonna create the asteroid. So we'll right click, blueprint class. I'm just going to use a basic actor is good enough for this. We'll call it BP_asteroid. You can double click to open that up. And then I want to press Control Spacebar, and I'm going to select my static mesh, hit add, and makes a reference to that static mesh, so I can just select it and then press enter to lock in my selection. Now I want this to be the default scene root, so I'm just going to drag it up and replace that because I don't really need it. And it's going to make the, we're going to be using similar code that we used on the ship and the laser fire that teleports the rock from one side of the screen to the other when it reaches a certain threshold or bounds. But you might as well add the material, so I can go to my materials folder, select my asteroid, pop that in there, and now this looks a little bit more like the rock I created in Blender and textured in Marmoset. But any static mesh will do, you can use any rock, doesn't really matter. Okay, so we need to make a few adjustments. First thing we need to do is we're going to be simulating physics, so we'll check that. This rock is a bit too small, so I am going to scale it to double. And then in the classic Asteroids game, I think there's 3 different rocks. There's a large, medium, and small. So normally I'd make 3 different rocks, but I'm just going to use the same one, and I'm just going to scale it at 2, 1, and then 0.5. And I think that'll get the job done. You can, of course, do it however you want to do it. So you can see the mass. I'm going to call this out because this is important. You could code 3 different blueprints for 3 different rocks, but I think for this prototype, I'm just going to code 1. And I'm just going to get a reference to the mass, and if it's above a certain threshold, I'll spawn smaller rocks, and if it is the smallest rock, I won't spawn any more rocks. And that'll be how we handle that, but I'll go over that later. The linear dampening, we need that to be 0, because we want these rocks to never stop. They're just going to float forever. The angular damping will also be 0, and enable gravity, we want that off. For the constraints, although this is a 3D game, we are treating it like a 2D game, which means we are only moving in the XY. So we want to check the box for the Z axis so it does not move up or down. We basically kind of want this to be more in line like a Cartesian grid, and the camera will just be top down. So the rotations are fine because we can allow those to go through, that won't be an issue. But I think that's good for the settings, so we can compile that. We do need to add another component. So like right now, if I drag this in the scene, I zero this out, although it just saved right there. There we go. and I move this slightly ajar from the center of the world, and then I push play. It is very boring. I can move it, of course, because it has physics, but we might as well get it spinning, right? So there is a built-in script under the Unreal Engine's components. You can hit add and just search rotating movement. And this rotating movement has a rotation rate. So let's come into the event graph and we'll adjust that programmatically off the begin play. So off the begin play, we can use two values. So we'll do a random float in range, and this takes a min and a max. So we can basically create these two floats as variables, and we'll call it min rotation, and that'll be a float, and we can make it public. And then we can make a max rotation and make that public by clicking the little I there. That just exposes the variable, so if you wanted to add them in your scene and adjust them over here, you can. That is optional. I think for a minimum rotation rate, let's see what I probably will use, maybe a do 15 degrees, and then for the max rotation rate I'll do 90 degrees, and then you can just plug these in here. And now we need to basically make a rotator, so we can come off this float and do make rotator. There's a few ways you could do this, I guess. So if we take the rotating movement component and we drag it in the scene, we can drag off that and do rotation rate or set rotation rate. So you can right click and split this, and you can input the pins manually that way. Or what you can do is come into a make rotator and then just plug the rotator in and do it that way. So it doesn't really matter which way you go. Both are fine. I'm going to organize this a little bit better. Although I think I will do it right like that. And then I'll move this one up over here. Okay. So now we have a roll or an X. You could create separate random floats and range. It'll do different ones, but I think for this example, I'm just going to keep it simple, and I'm going to plug the same random number into all three. And just with that, because that's on the begin play event pin, this thing should start spinning. And it'll spin randomly each time you play. So it's working pretty good. And like I said, you could set different ones for each, whether it's the roll, pitch, or yaw, that's optional. But I think that's probably good enough for this prototype anyways. But that's getting it spinning. It still needs to move. So the way we can actually get the movement going is we can add an impulse, since we're using physics. So let's actually give it a little bit of a delay so we can see it in action. We'll do maybe 3 seconds. And then we can come into an add impulse. And it makes a reference to our static mesh, which is what we're moving. We want to check the box for velocity change. And now we need to figure out the impulse value. Let's create another variable. This one's going to be a force, and I'm going to make this one a vector. And then I'm moving on the X and the Y. Remember, we're not doing the Z. So I'm just going to start off with 10 on the X and the Y, and then the Z I'll leave at 0. I can then drag that in, get a reference to it, and then maybe do a multiply. And then I have this set up right here. I'm actually going to hold control and drag this into a bottom pin. And on this pin, I'm going to come into a split. because I am not going to be modifying the Z, and I'm not going to be making a rotator. So I'm going to do this one a little bit differently. But we'll plug the result into impulse. But it's going to be more of the same, so we're going to do a random float in range. And now we can plug this into the X. And you have a few different options here. We could just plug this into the Y and the X, or you can duplicate it and plug this one into the Y, and that way you'll get a slightly different behavior just with that setup, because it's going to be it's not going to be the same random number generated for both the X and Y. It'll be slightly different, and it's important to do it on this one, because if you don't, and you may want the behavior, but your asteroid will basically only move in one direction like every single time. So it might be diagonal, you know, from bottom left to top right. But if you want it to basically come in from any direction, you'll want to use two separate random ranges. Otherwise, you're going to get the same kind of behavior both times. Let's create some more variables. We're going to do a min impulse. This will be a float, and we can make that public. And I think for the minimum impulse, we'll do 15 starting off, so I can kind of show you what I meant. And then we'll do a max impulse, make that public, and we'll set that to be 100. And then we can basically plug this into the min values, and we can plug this one into the max values. So after 3 seconds, this thing should launch. Let's see what it does. So it goes that direction. So now if I play again, it's kind of still going that direction. And it's going to continue to go that direction because we are using only positive values. I think so. So if you want it to kind of go anywhere, you want to make sure that your min and your max represent both negative and positive values. So if I did like negative 100 for that, and then positive 100 for that, we should get some slightly different behavior where it can go the other direction now. That's kind of what we're looking for. All right, so right now we got the rotation, we got the movement, but as you just see, when it leaves the screen, it never comes back. So let's see if we can fix that. We technically have that code already done in the laser in the ship, so we can kind of probably steal it. If we go into the ship, we have tick code, basically does a branch check. It teleports the actor based on if the object is, you know, outside of these bounds that we set. So it's pretty straightforward. So I'm gonna copy this code, and then I can come into tick. We'll drag this up here, paste it in. I think maybe I'll actually drag it up a little bit higher. Now the asteroids, because they're larger, these values are not quite right. They probably should be adjusted on the ship too, but for the X values, we did negative 2000 and 2000. I find that negative 2100 to positive 2100 is good there. And then for the Y, I found negative 3500 and 3500 seem to work better. All right, so now if we play that, kind of move the ship out of the way, this thing should hopefully teleport to the bottom, and you kind of see it there, and then it'll kind of shimmy on the side, and then it should, I think, come down there. And now maybe we come to the level and we can add maybe a few more rocks here. And then we can kind of see what this looks like. And you kind of get some random rotation and movement. And we got what's beginning to look like a traditional Asteroids game. So that takes care of the rotation, takes care of the movement, and it takes care of the screen position, but we cannot destroy the rocks. So let's see if we can fix that. Destroying of the rocks is basically kind of done through the laser code, so or the laser blueprint. So if we open that up here, we basically just need a custom function because we need to do two things. We need to destroy the laser, because right now the laser only gets destroyed after 0.75 seconds. So we need to basically, like, when the laser hits something, it shouldn't go through it, it should be destroyed. And then we also need to destroy the asteroid, of course. So let's create a custom event. We'll call it, I don't know, I hit something, doesn't matter. Come off this into a simple destroy actor. This won't run unless it's called, right? So we can come into the asteroid blueprint. There is a begin overlap code here. And if we wanted to, we can come off this into a cast2bp laser, plug the other actor into the object. If that is successful, it'll call this code. If it fails, it'll call this code. So on the success code, I can just, actually as the laser, I hit something, and then that should take care of the laser. So now if I shoot, you can see the laser doesn't go through anymore. But if I miss, you can see it kind of destroys after the 0.75. But if you want to actually destroy the actual asteroid, we're going to need to come into another custom function. So we can write maybe custom event, and then I got lasered, whatever you want to call it, doesn't matter. And then off this, just call I got lasered. And then if you just want it to be simple, you can call into a destroy actor. So now if I shoot the asteroids, they kind of destroy just like that. But that was kind of boring and not exciting, and also not very reminiscent of the classic game. So typically what happens is the asteroid will, if it's a certain size, it'll split into like a medium asteroid, and then those medium asteroids will, if they get shot, they'll split into a smaller one. So what we can do instead is we can do a reference to the asteroid. We can say get mass, and then if that mass is greater than some value, plug that into a branch condition, and if it's big enough, do this. If it's small enough, do this. So if you remember when we were looking at the mass, this thing was 10,000? Yeah, 10,000. If I set it to 1, it's 2,100. If I set it to 0.5, it's 450. So those are our mass values. Yours is going to be different depending on the static mesh you use. So you may not be using my values if you're doing it through this method. If you're creating 3 separate rocks, you just spawn the separate rocks, so it's not a big deal. So I'm going to say if this thing is bigger than, say 5,000, then what I want to do is come into a spawn actor from class. I want to spawn the asteroid, and I want to split the transform because I need access to the location and the scale separately. And I'm not going to mess with the rotation because that's inherited on the begin play. The scale I want to do is actually 0.5. And you may be thinking, why don't we do a scale of 1? Well, the scale right now is 2. If you set this to 1, it's going to come in as a 2 because that's just the way this does it. So if you do 0.5, it's actually going to bring it as a scale of 1. And then a 0.25 will be a scale of half, just because of the way we have it set up here. And then the transform location, the way we can get that is we can just drag the asteroid here and just get world location for the transformation. And then you just plug that in here. Now typically it spawns 2 rocks, so this is 1, so we can just duplicate this, and there's your second one. And then we also need to come into a destroy actor because it's got to destroy the original rock, right? And then on the false pin, you're going to kind of do the same thing. So we're going to come into another branch, and then we're going to duplicate the get mass, and we can say if this is greater than, I don't know, say 1,000. Probably not the greatest condition check because this should never evaluate to false in this scenario, so we should be good, but if you wanted to be more precise, you could. But I think this will work just for this example. We're going to kind of do more of the same. So we can just duplicate this code down here, but the only difference being we're going to scale at 0.25. Like that. And then we still come into a destroy actor, and then the last one we come into is a destroy actor. Basically, if it's already the smallest version of the rock, just go ahead and destroy. All right, so let's see how that gets along. So wait for these to start moving so I can split those off. Those split again. That just shot me across the screen. Where am I? Oh, here's the other issue you can see. Right now I'm actually floating up. So we will want to come back to the ship, and we will want to select our collider. And there is a gotta find where it's at. Here it is, constraints. We want to lock the position for the z-axis. Normally that won't be an issue because you're destroying the ship when you get hit, but we haven't got there, so that'll basically take care of that edge case. So that splits, that splits. That splits. Oops. And then that just destroys, so you can see that's kind of working just fine. And then we're starting to get kind of the remnants of an actual Asteroids game. Now there's a issue with the code that we'll deal in the next video where the asteroids kind of look like they take off after a while, and that has to do with the we added a delay on the begin play that actually adds an impulse, so we're gonna have to check for that when we spawn them, but we're gonna need a game manager to do that because we're destroying the object, so we'll take care of that little bug in a later video. But I think what I want to do now is I think it's still a little bit boring, so we're gonna want to add some special effects. So let's go to our materials. We'll create a new material, call it M underscore, I don't know, rock explosion. And then I'm going to use a simple unlit material. So I'm going to come into, we need a multiply node. We're going to need a lerp node, so hold L, click in the graph, and for a multiply node you can just hit M, click in the graph, or you can select from your palette. And then we need some constant 3s, so you can just drag constant 3 vectors, or you can just hold 3 and then click in the graph. And then we're going to plug the basically the colors in there, multiply in there. I'm going to multiply it against just 100, pop this in the emissive, And then for the first color, I'm gonna go maybe red. And then for the second color, I'm gonna go white. And then for the alpha, we're gonna be doing that programmatically. So in order to do that, we need a scalar. We already have a scalar. I believe it was under textures. We can add the MPC space that we made from an earlier video. And then we just need to create a parameter for this setup. So let's just go ahead and open up our material parameter collection. We'll hit the plus sign to add a new parameter. And we can just call this one rock explosion. I'm going to use a default value of 1, so it's white. And then I'm going to set that parameter name to rock explosion. I'll plug that into the alpha, and then this material is good to go. Let's go ahead and create the Niagara system. So come to my SFX folder, do a new Niagara system, and we can use a template. We can use an omnidirectional burst. And I'll just call it ns underscore rock explosion. This one's going to be pretty simple. I think what we'll do is we will get rid of gravity. We'll get rid of drag. We'll increase the velocity to maybe 200, 400 for the min-max. For the particle size, we'll double it to maybe 614, so it's a little bigger. And then for the spawn rate, we'll start with maybe 1,000, just to make it real crazy. And then for the sprite render, we're going to use that material that we created as the renderer, so it's nice and kind of fits with our art style, which is very squares and blocks and kind of goofy, I guess. Now that sets the materials up, but we got to adjust the color through code. So you need to pick a game object that's going to be around to do that. And I think starting off, we'll probably put it maybe in the level blueprint, or we might do it in the game manager, but I think just for this, we'll stick it in the ship for now. We'll see how we make off with that. But the ship already has a timeline, which is why I kind of want to put it here. So what we can do is we can actually duplicate this scalar value. And instead of the tail light, we'll adjust rock explosion. And then we can come to our timeline and we'll just add another track, another float track. And we'll just call this rock explosion. We have to stick with 4 seconds, but that's fine. We can make that work. We'll just add a couple keyframes. We'll do one at 0, 0. We'll do another one at 4, 0, and one in the middle with 2, 1. And then we want to auto interpolate, so it's nice and a smooth curve. And then compile and save that. And now we have the rock explosion. We can just pop that into there. And then that part's good. But we do need to spawn the system. So the best place to do that is, of course, on the asteroid, on the death code or the I got laser code. I think we can just probably pull this back a bit and go into a spawn system at location. I think that looks okay. And the system we want to do is our rock explosion. And we need to figure out the location. We can just drag our asteroid out here. And then we'll just get a world location for the transformation one. We can pop that into the location. I don't think we need to do anything else with scale or anything, so we can probably just compile that, save. And now if we start shooting this stuff, we get these cool little firework looking effects where it goes kind of like white to red. And we're sort of getting these it looks a little bit more interesting visually, I guess, for the game. And you can kind of move around and do whatnot. Now the other thing that we want to adjust before I forget is if I hit a rock, probably won't work too well. Yeah, I'm not really getting hit too well, but there is a, if you go back into the blueprint ship, you will want to adjust the angular dampening right here, because it's at 0, so if a rock hits you, it's going to continually spin you forever, so you might want to do like a 0.6. I mean, that probably won't be too much of an issue, depending on how we handle the death code, because obviously if a rock hits you, you should be exploding and dying, but if we spawn a new actor, it's not a problem, but if I decide to maybe use the same blueprint actor, it's going to be an issue, so we might as well just code for it now, so we don't have to worry about it later. But alright, alright people, I think we'll cut the video here, because it's already getting kind of long, but in the next one, we'll work on coding the game manager to handle the scoring and spawning of the asteroids. But as always, thanks for watching, consider subscribing, and see you on the next one.